Hello everyone, myself Vans. Today we are going to solve the given problem based on Charpit method of UPSC 2017. Here in the UPSC asked in 2017 for 15 marks, find a complete integral of the partial differential equation. And the equation is given by 2 bracket pq plus yp plus qx bracket plus x square plus y square is equal to 0. This is the important problem. Let's solve the problem. Let given differential equation is f of x y z p q is equal to 2 times of pq plus yp plus qx and plus of x square plus y square is equal to 0. Let this is equation 1. We use the following problem with the help of Charpit method. First, we know the what Charpit method. Using Charpit method to solve the given problem. We have to know the Charpit auxiliary equation. We must remember the following Charpit auxiliary equation. We must remember to solve the given problem. We have to must remember Charpit auxiliary equation. Charpit auxiliary equation is given by dp is equal to dp upon del f upon del x plus of p del f upon del z is equal to, and dq is given by dq upon del f upon del y plus of q and del f upon del z, and dz is given by minus of p del f upon del p and minus of q del f upon del q, and dx is given by minus of del f upon del p and dy is given by minus of del f upon del q. We have to must remember the following Charpit auxiliary equation to further solve the given problem. Then further we have to find the del f upon del x plus p del f upon del z and del f upon del y plus of q del f upon del z and minus of p del f upon del p and minus of q del f upon del q and minus of del f upon del p and minus of del f upon del q. We have to find with the help of given equation 1, and further we have to put in the Charpit auxiliary equation. First we have to find del f upon del x plus p into del f upon del z. We have to first find del f upon del x using equation 1. Del f upon del x, that is from the coefficient of del x is 2qx, and when differentiating partially with respect to x, 2qx, that is 2q, and again differentiating x square with respect to x, that is 2x. Further plus of p and differentiating partially equation 1 with respect to z. Here in the given question the coefficient of z is not present, so we have to all function is 0. Then this is the value of del f upon del x plus of p and del f upon del z is equal to 2q plus 2x. Further we have to find del f upon del y del f upon del y plus of q and del f upon del z. Again using equation 1, differentiating equation 1 with respect to y partially. Then the coefficient of y is here 2py. Differentiating with respect to y, that is 2p, and y square differentiating with respect to y, that is 2y plus of 2y. And further we have to solve plus of q, and again del f upon del z. Here is the coefficient of z is not present, so this is 0, and the remaining is 2p plus 2y. Further we have to find minus of p del f upon del p and minus of q del f upon del q. That is minus of p del f upon del p and minus of q del f upon del q. We have to find, that is taking minus p is common, and we have to find multiplication del f upon del p using equation 1. From here the coefficient of p is here 2pq, differentiating partially with respect to p, that is 2q, and again 2yp differentiating with respect to p, that is 2y plus of 2y, and plus minus of q, and again differentiating del f upon del q. Del f upon del q here is 2pq, del f upon del q with respect to q, that is 2p, and again from here that is 2qx differentiating partially with respect to q, that is plus of 2x. This is the value of minus p del f upon del p and minus of q del f upon del q. Further we have to find minus of del f upon del p, that is minus of del f upon del p. We have to find, that is we have to differentiate equation 1 partially with respect to p, that is here is 2pq, that is 2q, and from here is 2y 2qx, that is differentiating partially, then 2py differentiating with respect to p, that is 2y plus of 2y, and this is the value of minus del f upon del p. Further we have to find minus del f upon del q. Differentiating equation 1 with respect to q, that is from here 2pq, differentiating with respect to q, that is 2p, and from here is 2qx, differentiating partially with respect to q, that is 2x. This is the value of minus del f upon del p and minus del f upon del q, and from here that is del f upon del x plus p del f upon del z, and del f upon del y plus of q del f upon del z, and minus of p del f upon del p minus of q del f upon del q. We have to put the value in the Chapit auxiliary equation. First we have to put minus of del f upon del q. That is the value of minus del f upon del q is minus of 2p plus 2x, and we have to put again the value of del f upon minus del f upon del p, that is minus of 2q plus 2y, and further we have to put the value of minus del f upon del p and minus of q del f upon del q. Putting here, that is minus of p and 2q plus 2y and minus of q 2p plus 2x, 2p plus 2x. Further we have to put the value of del f of del y plus of q del f upon del z. From here we have to find, that is 2p plus 2y. 2p plus 2y. And last one we have to put del f upon del x plus of p del f upon del z. This is the value 2q plus 2x. 2q plus 2x. Further we have to solve. Further we have to solve taking, this is the first and this is second and this part is third and this is fourth and this is 5. Taking first, second, fourth and fifth. We have to solve taking as a multiplier this one, that is dp plus of dq plus of dx plus of dy upon, here is 2q plus 2x and from here is 2p plus 2y and the dx coefficient is minus of 2q and minus of 2y and from here is minus of 2p and minus of 2x. We have to solve from here, that is minus of 2y and plus of 2y is cancelled out and minus of 2p and plus of 2p is cancelled out and plus of 2x and minus of 2x is cancelled out and plus of 2q and minus of 2p is cancelled out. Then the remaining is dp plus dq plus dx plus dy upon 0. We have to take, that is dp plus dq plus dx plus dy is equal to 0. On integration both the sides, that is on integrating dp with respect to p, that is p, and again different integrating dq with respect to q, that is q, and from here on integration of dx is x and integration of dy is y, and let constant, that is c. We can also arrange, that is p plus x and plus of q plus y is equal to c. Let this equation 2. Further we have to solve. Further we have to solve. We know the following identities, that is a minus b का whole square is equal to a plus b का whole square minus of 4ab. We know the following identities to solve the given problem. Using in this problem to solve, that is px plus p plus x minus of q plus y का whole square is equal to, we have to write, that is p plus x and plus of q plus y का whole square and minus of 4ab, that is p plus x and q plus y. We use the following identities. A minus b का whole square is equal to a plus b का whole square minus 4ab. We use in the following problem, that is taking p plus x is a and q plus y is b. That is a minus b का whole square is equal to a plus b का square minus of 4ab. Further we have to solve. That is p plus x minus of q plus y and square is taken into this side, that is equal to under root of p plus x and q plus y का whole square and minus of 4 p plus x and q plus y. We have to put the value of p plus x and plus of q plus y in the following. First, using the equation 1, equation 1 can be written as that is 2pq plus of 2yp and plus of 2qx plus of x square plus y square is equal to 0. We have to know first, from here we have to add 2pq plus 2yp and plus of 2qx, and from here we have to minus of 2xy and plus of 2xy. X square plus y square is equal to 0. Nothing to affect the above equation. We have to add plus 2xy and minus 2xy. Further we have to solve, that is 2pq plus of 2yp and plus of 2qx and plus of 2xy, and we have to know a minus b का whole square is equal to a square plus b square minus 2ab. We also use the following identities. Here is x square plus y square and minus of 2xy. We can also write that is x minus y का whole square is equal to 0. From here we have 2x minus y का whole square is taken to right hand side, that is 2pq plus 2yp and plus of 2qx and plus of 2xy, and bracket x minus y का whole square is taken to right hand side, that is minus of x minus y का whole square. From here we have to take 2 common from left hand side, that is taking common 2, that is pq plus yp plus qx and plus of xy is equal to x minus y का whole square. Here the sign is minus. Taking 2 into denominator of minus x minus y का whole square, that is we can also write pq plus yp and plus qx plus xy is equal to minus of x minus y का whole square upon 2. And from here we have to also solve for taking pq and qx in one bracket and yp and xy in one bracket. When taking pq plus qx in one bracket, taking q is common, that is p plus x plus of and taking yp plus xy in one bracket taking y as a common, that is p plus x is also is equal to minus of x minus y का whole square upon 2. And from here you can also write that is q plus y and p plus x is equal to minus of x minus y का whole square upon 2. From here we have to put the value in the above. We can also write the equation third. This is the third. We have to put the value of p plus x and q plus y in the equation third. From here, that is the value is minus of x minus y का whole square upon 2. And from equation second we have to put p plus x and q plus y is equal to c square. Further we have to solve once again. Putting the value, that is p plus x and minus of q plus y is equal to, from here we have to put the value, that is under root of, in place of p plus x and q plus y we have to put c, that is c square, and minus of 4, and place of p plus x and q plus y we have to put minus of x minus y का whole square into 2, that is minus of x minus y का whole square upon 2. We have to solve, that is under root of c square, and from here 2 2 are 4 is cancelled out, and minus minus is plus, that is plus of 2 x minus y का whole square. This is p plus x and minus of q plus y. This is equation 4th. We have to use, then further we have to solve adding equation second and fourth. Further we have to proceed. Adding left hand side to left hand side and adding right hand side to right hand side. Now from here, equation second of right hand side is p plus x plus of q plus y, and equation 4 of left hand side is plus of p plus x, and here is minus of q plus y. Further in the right hand side of equation 2 is c, and the right hand side of equation 4 is under root of c square plus 2 and x minus y का whole square. From here we have to eliminate some identities, that is p plus x and q plus y, and also p plus x, and here is minus of q and minus of y is equal to c plus under root of c square, one second, c square plus 2 x minus y का whole square. From here, that is plus of q and minus of q is cancelled out, and minus of y and plus of y is cancelled out. Remaining is p plus x and p plus x, that is 2p plus x is equal to c plus under root of c square plus 2 and x minus y का whole square. Let this equation fit. Further we have to solve subtracting equation fourth to second. Subtracting left hand side to left hand side and right hand side to right hand side. We have to subtracting p plus x here is and minus of q plus y, and left hand side of equation 2 is minus of p plus x and plus of q plus y. And the right hand side of equation 4 is under root of c square plus 2x minus y का whole square, and equation second of right hand side is c, that is minus of c. Further we have to solve that is p plus x and minus of q and minus of y, and from here is minus of p minus of x minus of q and minus of y is equal to under root of c square plus 2 x minus y का whole square minus of c. From here that is minus of p and plus of p is cancelled out, and minus of x and plus of x is cancelled out. Then the remaining is minus 2q and minus 2q and minus of 2y is equal to under root of c square plus 2 x minus y का whole square minus of c. Here multiplying minus with both the side, that is 2q plus 2y is equal to, on multiplication both the side with minus, that is this is minus and this is plus, taking c is first, and this is minus under root of c square plus 2 x minus y का whole square. Let this is equation 6th. Further we have to solve eliminate 2q plus 2y and 2p plus 2x. Once again, using from here we have to find the value of q. We can also find the value of q from here, that is once again, that is 2q is equal to c minus of under root c square plus 2 x minus y का whole square, and taking 2y into right hand side, that is minus of 2y, and from here we have to find the value of q. Then q is equal to, taking 2 into denominator of this function, that is c by 2 and minus of under root c square प्लस 2x माइनस y का होल स्क्वायर अपॉन 2 and we can also put in the denominator of 2y, 2 that is minus of y. This is the value of q, and from equation 5 you can also find the value of p, that is from here, that is 2p is equal to, from here we can 2x is taken into right hand side, that is c plus under root of c square plus 2x minus y का whole square and taking 2x into right hand side, that is minus of 2x. And from here we have to find the value of p. 2 is taken into the denominator of this function, that is p is equal to c by 2 plus under root of c square plus 2x minus y का whole square upon 2, and we can also put the denominator 2x into denominator, that is minus of x. Further we have to use in Chapit method, that is xy. We have to put the differential equation, that is dz is equal to p dx plus q dy. We have to put the value of p and q in the above equation, that is dz is equal to, we have to put the value of p first, that is c by 2 plus under root of c square plus 2 c square plus 2x minus y का whole square upon 2 and minus of x. We have to put the value of p into dx, and further we have to put the value of q, that is q is c by 2 and minus of under root c square plus 2 x minus y का whole square upon 2 and minus of y into dy. Further we have to solve the given equation. Further we have to solve the given equation, that is dz is equal to c by 2 dx, and from here is plus of under root c square plus 2 x minus y का whole square upon 2 dx, and from here is minus x dx. We can also multiply here, that is plus of c by 2 dy, and from here that is minus of under root c square plus 2 x minus y का whole square upon 2 dy and minus of y dy. We have to take dz is equal to, we have to take c by 2 dy and c by 2 dx in one bracket, that is c by 2 dx plus dy, taking c by 2 common, and we can also let, that is minus of x dx and minus of y dy in one bracket, that is minus is taking common, minus, one second, c by 2 and dy, once again we have to take common from here, that is plus of under root c square plus 2 x minus y का whole square upon 2, taking common, taking this function and this function in one bracket, and we have to take, that is remaining is dx minus of dy, and further we have to also write, that is minus of x dx and minus of y dy. Further we have to integrate, and we can also write from here dx minus dy is also written as dx minus y, nothing to change. Integrating both the side, once again we have to dz is equal to c by 2, and from here is dx plus dy and plus of under root c square plus 2 x minus y का whole square upon 2 we can also write, that is d is taking common x minus y, and from here that is x dx and y dy. Further we have to let x minus y is equal to t, and from here that is dx is equal to dt. We have to write dx is equal to dt. Further in the given question, that is dz is equal to c by 2 and dx plus dy, and from here is plus of, once again we have to take 2 is into bracket, taking 2 common, we have to, from here we have to take 2 common, and 1 by 2 is already present, and taking 2 common in the root, that is into root 2 and under root of c square upon 2 plus, in place of x minus y we have to put t, that is t square, and in place of d x minus y is equal to t, that is this is dt, and from here is x dx minus of y dy. From here we have cancel out root 2 to 2, and we can also, root 2 is written as root 2 into root 2, then remaining is root 2. Further we have to write dz is equal to c by 2 dx plus dy and plus of 1 by root 2, and in the root we have to write c by 2, that is c by root 2 का square on squaring, that is c square upon 2 plus of t square dt and minus of x dx and minus of y dy. On integrating both the side, that is integration of dz is z, and it is equal to c by 2, and integration of dx is x, and integration of dy is y, plus of 1 by root 2, and integration of a c by root 2 का होल स्क्वायर प्लस t स्क्वायर dt using the following identities. We must be remembered integration of under root of a square plus x square dx, that is written as x by 2 under root of a square plus x square plus of a square upon 2 and log x plus a. We have to write using the following identities to apply in the given question and integrating both the side, that is dz is z and is equal to c by 2 dx on integration is x on integration of dy is y plus of 1 by root 2 and from here a square is c upon root 2 and t square is x square. Further we have to write x by 2, that is x by 2 is t by 2 and under root of a square is c upon root 2. We have to write c upon root 2 का whole square a square and plus of x square, that is x square is t square and further plus of a square is c by root 2, that is c by root 2 का square upon 2 log x plus a, that is x is here is t and a is plus of c by root 2. We can also write in the mod, nothing to change. Then further we have to integrate minus of x dx, that is x square by 2 and minus of y dy integrating with respect to y, that is minus of y square by 2 using the formula x and dx integration xn plus 1 and n plus 1. Further we have to write z is equal to c by 2 x plus y plus of 1 by root 2 and we have to put the value of t, let here x minus y, so we have to put in place of t, that is x minus y upon 2 and from under root c square upon 2 and plus we have to put the value of t, that is x minus y का whole square plus here is c upon 2, that is c square upon 4 log c square upon 4 log, in place of t we have to put x minus y and in place of c by root 2 and minus of x square by 2 and minus of y square by 2 and taking another constant on integration, here is taken c dash. We can also write this is the required solution of the given problem and we can also arrange in the form of, we can also write in the form of, that is z is equal to taking minus of x square minus of, once again taking minus common, minus 1 by 2 is common, that is x square plus y square plus of c by 2 x plus y and plus of 1 by root 2 plus of 1 by root 2 and x minus y upon 2 under root of c square upon 2 plus x minus y का whole square plus of c square upon 4 log mod of x minus y and plus of c root 2. This is the required solution of the given problem. Thank you for watching. If you like my video, kindly like, share and subscribe my channel. प्रियांशु तुम ज्यादा पढ़ाकू हो जाते